In this screencast, we're going to learn all about solving linear inequalities. Now we have two main properties we can use to solve inequalities. The first is addition subtraction property of inequalities, and what it says is that basically you can add or subtract the same thing to both sides and it won't change the inequality. The second one is the multiplication division property of inequalities, and here we have to be careful. We can multiply or divide by the same thing, making sure that if we don't divide by 0. If it's positive, it stays the same. But if the thing we're multiplying by is negative, it switches the inequality. So that's what we have to watch out for. If we start with less than and we multiply or divide by a negative term, it's going to become greater than, and vice versa. So let's look at this example. Solve 2x plus 1 is less than 7. So I'm going to subtract 1 from both sides. That'll give me 2x is less than 6. Then I'm going to divide by 2. Since 2 is positive, it doesn't change the inequality, and x is less than 3. If we graph the solution of this on a number line, we would have an open circle at 3 because x is less than but not equal to 3, and we shade everything to the left. Okay, let's look at this question here. We're going to add 2 to both sides. So I get negative 3x is less than or equal to 12. Now I'm dividing by a negative term. So I'm going to get x is now greater than or equal to negative 4. If we graph this on a number line, I'm going to have a closed circle at negative 4 because x can equal it. And we will shade everything to the right because x is greater than or equal to negative 4. Compound inequalities are two inequalities that are joined by either the word and or. And so you can see that we have an or in here. So we're just going to solve them separately and then put them together at the end, okay? So 2x is less than 10. That means x is less than 5. Or x plus 1 is greater than 9. So x is greater than 7. Whoop, what am I thinking? X is greater than 8. There we go. So x is either less than 5. So I'm going to put an open circle at 5, or x is greater than 8. And so I'm going to shade to the left of 5 and to the right of 8. Now if we put this in interval notation, we would say that x equals negative infinity to 5 in union with 8 to infinity. Let's solve this compound inequality. Now I've got x plus 3 is greater than 4, so x is greater than 1, and 2x is greater than 14, so x is greater than 7. If we graph this on a number line, I've got an open circle at 1, and x is everything greater than 1. And I have an open circle at 7, and x is everything greater than 7. Well, what do we take? We take the area where it overlaps. Okay, so we're going to go with this area here, the area that's true for both of them since it's an and question. Okay, so our final answer is x is greater than 7 in interval notation. X is going to be 7 to infinity. Sometimes compound inequalities are written like this: a less than b less than c. That's the same thing as saying a is less than b and b is less than c. Okay, our last type of inequality question we're going to deal with are absolute value inequalities. And it says that for any variable expression e and any non-negative real number k, if e is less than or equal to k, then we're going to get an answer like this. Negative k is less than or equal to our expression, less than or equal to k. If the absolute value of e is greater than or equal to k, we're going to get e is less than or equal to negative k, or e is greater than or equal to k. Now don't worry, that looks complicated, but it's actually pretty straightforward. So let's do an example of an absolute value with a less than, okay? I'm going to go 2 minus, let me erase that there, 2 minus 3x is less than 7. And then for the negative case, I'm going to flip the inequality so it's greater than negative 7. This means that negative 3x is less than 5. And over here, negative 3x is greater than negative 9. I'm dividing by a negative number, so x is greater than negative 5/3. And over here, dividing by a negative number, so x is less than positive 3. On a number line, here's our answer. I have an open circle at negative 5/3, and I have an open circle at 3. X is everything greater than negative 5/3 and less than 3. So in interval notation, x equals all numbers between negative 5/3 and 3. And for our last example, we'll do an absolute value inequality with a greater than. Okay, I'm going to start with 4x minus 3 is greater than or equal to 5. That's the positive case. And then I'm going to do the negative case and switch the inequality. So 4x is greater than or equal to 8. X is greater than or equal to 2. And over here, 4x is less than or equal to 2. Nope, 8. Whoop, sorry, messed up, didn't I? I said negative case, I didn't write negative 5. There we go. Okay, so negative 5 plus 3 is negative 2. So x is less than or equal to negative 1/2. So our answer is going to be an OR answer. X is greater than or equal to 2. So that's all of this, including 2. And, or x is less than or equal to negative 1/2. So that's everything to the left of negative 1/2. All right, in interval notation, we're going to say that x is negative infinity to negative 1/2 and or 2 to infinity.